the goal of today is not to really get real in-depth on teaching you everything, but just to go in and kind of show you the ropes, show you some really cool things, and hopefully help pique your interest so you'll come back and take a look at a couple of other MBA courses, in particular a few from Wintellect and some edX courses. But before we get into any of that, you're probably wondering who we are. Well, over on the left-hand side of me anyway, on your right, is Jeff Procyse from Wintellect. So Jeff, if you want to go ahead and introduce yourself.
I'd be glad to. Welcome everyone. My name is Jeff Procyse. I work for a company named Wintellect. We've been a Microsoft partner for many years, do a lot of fun stuff, training, content development, code writing, things like that. And it's a pleasure to be here. Actually an honor, Christopher.
An honor.
I think it's the same Christopher because the last time I saw you, your hair looked a little bit different, right?
Yes, I had hair at one point. A little bit different today, sort of a long story there. In any event, my name is Christopher Harrison. I'm a software development engineer now with DX inside of Microsoft. Before joining there, I spent quite a bit of time with MVA doing an awful lot of courses and otherwise on a whole host of different developer topics. So today, like I said, what we're going to be taking a look at is really kind of what Azure can do for you when it comes to trying to, I guess to a certain extent, predict the future.
Exactly. We're going to do that today.
Trends. We're going to predict the future. Excellent. So we're going to predict the future and then also see how we can deal with an awful lot of live data coming in. But let's start with predicting the future. So how can we predict the future, Jeff?
Yeah, that's a great question, Christopher. And so we are going to predict the future using a tool called Azure Machine Learning. So let me say just a little bit about what we're going to do and how we're going to do this today. Data science is a big deal these days. If you're a data scientist, if you're a trained data scientist, you are degreed in that. There are a lot of companies that want your services. It's almost like being a software developer was 20 years ago when everyone needed software developers. In fact, it's still that way today. The unemployment rate among software developers is just about zero as far as I can tell.
It certainly seems that way.
In the future, you know, if I were going to school today, Chris, and I'm a little too old to go to school.
You're never too old.
Never too old. If I were going to school today, I would strongly consider doing something in data science because it's all about data going into the future. It's all about figuring out how to deal with the massive amounts of data coming from all these different places. And it's really interesting. For the most part, in my experience, developers don't think a lot about data. Yeah, we think about SQL Server databases and things like that and how to store static data. But in terms of data science, how do you extract information from that data? It's something that we tend to leave to the data scientists. But the message that I'd like to get across today is that as a software developer, number one, there's a lot you can do with data science as well. And number two, if you care about future employability, if you want to be valuable to your employer as a contractor or whatever, I believe it behooves every developer in the world today to learn something about data science. Because it's not just something for data scientists. Those data scientists often need software developers to build stuff around what they're doing with the data. So that's what we're going to do today, Christopher.
Okay.
We're going to look first at Azure Machine Learning. We're going to build a model. We're going to do predictive analytics. We literally are going to predict the future.
I like it. Okay.
But rather than stop there, which we often do in sessions like this, we are then going to write an app that talks to that machine learning model in the cloud so that we can take that functionality and put it in that app, in an iOS app, in an Android app, in a Windows app, or what have you.
Okay.
In fact, I probably won't use Xamarin to do it, but I easily could. So that's how we're going to start. We'll start with Azure Machine Learning. We're going to talk about the basics of it, what it is, how you use it, and then show you how to build a model. So, and then we'll write some code around that model. So format-wise, I'm going to take about an hour to do this with Christopher's help. I'm going to spend just a few minutes with some slides just to sort of set the stage for those of you that haven't done much with Azure Stream Analytics before. And then we'll put the slides away and we'll build something.
Okay.
Right? That's what developers like to do.
Right.
They like to build something. So let's you and I build something. Let's start with just a few slides, just to make sure that we're all starting on the same page. So, what is machine learning? That's a great question to start off with. So machine learning, simply put, is the science of extracting information from data, typically in order to perform predictive analytics. Now, that sounds pretty academic. Let me tell you something a little bit more practical about machine learning. I travel a lot, just like Christopher does. I travel to different places all over the world. And I use my credit card a lot when I'm traveling, especially my American Express card. 3 times in the last 4 years, my credit card number has been stolen and someone has tried to use it fraudulently. And each time, within literally a few minutes of that happening, I got a call from American Express saying, did you just try to buy this at such and such a place? And each time my answer was no. So no problem, they voided the transaction. Now, here's the interesting thing. The very first time that happened, it was easy to tell that it probably wasn't me because I was sitting at my home in Tennessee. I got the call, and someone had tried to use my American Express card to buy a plane ticket in Brazil. So American Express asked, was that you? I said, no, I'm not even in Brazil. No big deal. The last time it happened, Christopher, someone had tried to buy a necklace, a fairly expensive necklace, at a jewelry store 2 miles from my house. And I said, no, that wasn't me. But I got really curious, and I asked the lady who called from American Express, how did you know that wasn't me? I mean, it's not like I never buy my wife anything nice, right?
Right.
Yeah, I do sometimes. So she said, sir, we just know. Well, let me tell you what they and other credit card companies are doing. They are training machine learning models with millions and millions of credit card transactions. And then they're using that model to feed in new transactions. And because of the training that was done in the machine learning model from those millions of transactions originally, it can tell me or tell them with a very high degree of accuracy whether that transaction is fraudulent or not. So the beauty of machine learning to me is it allows us as developers working with data scientists or working as data scientists ourselves to do things that would be almost impossible to do algorithmically. I mean, imagine writing that code to take all those past credit card transactions and looking for patterns in it so you can tell with 99.99% accuracy whether the next transaction is valid or not. That would be a difficult thing to do. In fact, I think it would be just about impossible. With Azure Machine Learning, that's not a difficult thing to do. So machine learning is the science of taking data, hopefully and potentially large volumes of data, and extracting information from it, finding patterns in it, so that we can perform predictive analytics, as in, is this credit card transaction one that should be tagged as fraud or not, based on what machine learning knows about those transactions that we've trained it with.
So basically what I'm hearing is that everything has a pattern.
Yes.
That, your somebody's credit card use is a pattern, but also somebody's, like shopping, that the number one example when it comes to machine learning is when you go to an e-commerce site.
Right.
And you add something to your cart and it says, hey, did you also want to buy this and this and this? And sometimes it's really, really good, like almost freaky, like, well, how did you know I was also going to want that? Which is pretty remarkable. Sometimes it's obviously not quite as good, and a lot of that, I'm going to guess, has to do with the data that's going to be going in, and has to do with the with how you've built everything with the model for machine learning.
That's exactly right. In fact, online shopping recommendations is one of those canonical scenarios that they often throw out there, and it really works. When I shop at Amazon or other places, I drop something in that shopping cart. It's uncanny how often they sell me something else.
Yeah.
Because they present to me something that, yeah, I'd like to have that as well, another book or another song or something like that. Here's the interesting thing to me, Christopher. Most folks outside of the data science community don't know what machine learning is, probably haven't heard of it. Even in the developer community, I don't think the cognizance of it is very high. And yet, as human beings, it's touching our lives every day. Every time we perform a credit card transaction, every time we buy something online, when you see a self-driving car going around, it's probably using machine learning. There are many, many applications. And that's one reason that I wanted to do this with you here today. Developers need to know about this because there's a tons of potential here for doing things, for building intelligent applications that would have been next to impossible to build without data science behind them, without Azure Machine Learning behind them.
Right. Cool.
Okay?
And just real quick, and I know you're about to get into one more slide here, but I just want to mention to our viewing audience out there that obviously this is live. You do have the Q&A window, so feel free to ask questions, and we'll do our absolute best to try and answer all of them as they pop up. So in any event, show us machine learning.
Yeah. So I've got a website and a slide here, and I could go out into the browser and try, but I'll leave that to the folks who are in the audience. So if you've never been to this website before, it's one that was built by Microsoft, by the way, has a lot of intelligence behind it from the fine folks in Microsoft Research, where they do really cool things with data science. It is how-old.net. You can go there in your browser, upload a photo of yourself or of a friend, and it does a couple of things. Number one, it uses some advanced pattern recognition techniques to extract information from that photo, like the distance between the eyes, the texture of the skin, and things like that. And then it feeds that information into a machine learning model, and it tells you how old the person in that picture appears to be. And it's almost scary. You can upload current pictures of yourself. You can upload pictures of friends, pictures of your kids. And most of the time, it'll nail it within a year or two. So it's a fun use. It's maybe not a practical use, but it is a way that you can see machine learning firsthand, how-old.net. So I do want to say a word or two about Microsoft's history with machine learning. Azure ML, as we call it, is fairly new. It's been around for 2 or 3 years. But that doesn't mean that Microsoft is new to machine learning. This is not exactly their first rodeo. Here's a timeline here showing some of the interesting products that Microsoft has used machine learning in over the years. And it starts way back in 1999. I remember Microsoft buying a company down in the Silicon Valley from which they formed Hotmail. I also remember Hotmail having one of the earliest and best spam filters. Well, can you guess what was behind that spam filter? It was machine learning. Think about this. Take that credit card example that I mentioned and apply that to email spam. You take millions and millions of emails, some spam, some not spam. You feed those into a machine learning model. You tell it which of them are spam emails and which are not. And then you let it find the patterns so that when the next email comes in, based on the training you've done, it can probably tell you with a very high degree of accuracy whether that email should be flagged as spam or not. In fact, almost all modern spam filters, at least the ones that work well, have machine learning behind them one way or another. So my whole point there is that Azure ML is not something Microsoft just sat around a table and came up with a couple of years ago. It really is the embodiment and the result of many, many years of expertise built up here at Microsoft in Microsoft Research and among the data scientists there. So enough about machine learning. You probably have an idea what machine learning is now. What is Azure Machine Learning? So Azure Machine Learning is a service offered by Azure. That means it runs out in the cloud. It's a fully managed software as a service, which means you don't have to install any software on your computer or anything like that. You just go into the Azure portal, fire up a machine learning model, do the building and the training and things like that, which you'll see Christopher and I do in a few minutes, and then let it do its thing. So I want to show you this thing firsthand because I think the best way to learn is to see it done or to even do it yourself. But I did want to point out a couple of things that are interesting about this. Azure ML probably makes it easier than any tool on the planet to build, train, and test your machine learning models. As you're going to see in a moment, it has this really slick graphical user interface in which you compose the workflow that define your models using drag and drop, and you drag arrows around and connect those modules together. So in terms of the user interface, it really makes it easy to build that model. But you know, oftentimes when something is really easy like that, it's also not very powerful. It's limiting. There are a couple of really important things I want to get across about Azure Machine Learning. One is that out in the data science world, specifically in the machine learning world, there are a couple of dozen algorithms that are used a lot in a lot of different models. Traditionally, when a data scientist or a grad student builds a machine learning model, they may use a package to do that, or they may just code it up themselves from scratch, often in Python, sometimes in R. The nice thing,
Arg.
arg, exactly.
Sorry, I had
Yeah.
to make that joke. I could not let that one slide.
You know, I own a parrot. If I thought about it, I would have brought him with me. He can sit right here on my shoulder.
See?
And do the arg thing.
See?
It's really, at Halloween, it's really fun to own a parrot, by the way. So
We missed that opportunity.
yeah, we missed the opportunity. But you know, there'll be future opportunities. So
Yes.
Anyway, a couple of things real quick about Azure Machine Learning I want you to know going in. Yeah, I'm going to use the graphical designer, which we call ML Studio, to build and train and do other things with the model. But realize that I'm just scratching the surface. If you're a hardcore data scientist, you've got a bunch of stuff coded up in Python or R that you wanted to use to customize that model, you can pour that code right into Azure Machine Learning and it will work. So another thing that's really unique about this, and I'll say more about this in just a moment and demonstrate it for you, is how you operationalize the model. So you build a great machine learning model. So what? You've got to be able to use it. Use it in your apps or use it wherever, right? One of the cool things about Azure Machine Learning is once you have a model built and finalized, with a couple of button clicks, you can deploy it to the cloud as a web service, which means the functionality of that model is now available using REST calls over HTTPS. I'm going to demonstrate that for you as well because in terms of operationalizing a model, setting it up in such a way that you can use it in the apps that you're building or the websites you're building, I would argue that no one makes it as easy as Azure Machine Learning does. So, I want to show you a quote here. One of the things I've been doing a lot of for the last year or so is going out with data scientists from Microsoft Research and visiting top universities around the world and talking to them about data analytics, Azure Machine Learning, Azure Stream Analytics, and other things. One of the things we do in these day-long classes that we do is we give people hands-on experience with Azure Machine Learning. When we did this at school in the Northeast, in fact, I'll just mention who it was, University of Massachusetts, which has a very, very fine data science program, a grad student sitting in class walked up to me after we did the Azure Machine Learning Lab, and he said, you know what? I just did in 10 minutes what I spent most of last semester doing when I hand-coded a regression model in Python. So he was suitably impressed. And the ending to that story, Christopher, is that Microsoft hired the guy. How about that?
Oh,
And
nice.
he now works for Microsoft. So you say good things about Azure ML, you get job offers.
Oh, is that how that works?
That's what I took away from it.
All
yeah.
right.
So just a little bit more in terms of slides, and then we're going to go into the portal and we're going to build something here. One of the tools that you're going to see me use when I go into the Azure portal is ML Studio. You're going to see how I use that to build a drag and drop model. So that's a screenshot there, but you'll learn a lot more when we actually do that. I do want to say a word about the machine learning process, sort of an overview of the process that we go through in ML Studio to build a model, get it ready to roll out, and then to operationalize it. And you'll see me go through this process. But I'm going to start by bringing in data. Machine learning starts with data. The more of it you have, the better. Doesn't really matter whether it's structured or not. In fact, in the real world, the data is often very, very messy, has to be cleaned up and prepared in various ways before it's used to train that model. So you can do that preparation of the data externally if you want, or you can do it right there in ML Studio because there are modules to help you clean the data by removing columns that don't have any influence on the output, or removing duplicate rows, or removing rows that have missing values. A lot of the things that data scientists do to prepare the data for their models can be done right there in ML Studio. After we get the data ready and we bring it in, what we then do is use it to train a model. And that's an important part of the process because that's the point at which we tell the model which machine learning algorithm we want it to use. And this is where it helps to know a little bit about data science because the model's probably not going to work if you just pick an algorithm at random. But Microsoft does offer something kind of cool to help those of us who are not PhD data scientists focus in on what set of algorithms to try. And by the way, ML Studio makes it very easy to try different algorithms and compare the results. Once you've picked an algorithm and you've trained the model, then you want to know how accurate it is at doing predictive analytics. So at that point, we go through a process called scoring the model. I'll do that in ML Studio. You'll see how it works. You'll see how easy it is to do. And if after the scoring process, I am satisfied with the accuracy of the model, then I will operationalizing it by pushing it out to the cloud, deploying it as a web service so that I can call it and leverage its functionality using REST calls over HTTPS. So that's the big picture in building a model, but of course it's all about the details. Real quickly back on the slides, I said that there are a couple of dozen algorithms built into Azure Machine Learning. This is a list of the algorithms that are currently built in. I'm not going to go through these one by one, but you can see how they've been categorized. And if you're new to machine learning, you should know that there are different kinds of machine learning models. But in the supervised learning category, which is by far the most common, supervised learning is generally done in order to do predictive analytics. There are two common categories of algorithms: regression algorithms and classification algorithms. The big difference between the two is that regression algorithms are typically used to do predictive analytics on numeric output, like taking a picture of a person, analyzing that picture, and trying to predict what age that person is. Classification algorithms, on the other hand, try to predict an output from a finite set of possible outputs. Two-class classification algorithm, for example, might be used to detect whether an email is spam or not spam, or whether a credit card transaction is fraudulent or not fraudulent. So regression algorithms and classification algorithms are the most commonly used. And I'm actually going to be using a classification algorithm that uses regression internally in the demonstration that I do. And let me go back here to the slides for just a moment. If you go to the URL shown on the right side of the screen, you'll find something really cool called the Azure ML Cheat Sheet. So if you, like me, are a software developer, but you're rather new to data science, one of the things you're going to find when you're building a model is you have to pick an algorithm, and you need some expertise, some knowledge in order to know which algorithm to pick. Well, Microsoft realizes that a lot of developers are going to be using Azure ML, and not all of them are data scientists. So they give us this cheat sheet, which you can download online as a PDF. And it's just a way to get oriented. Based on what you want to do with your model, it helps you decide which algorithm you might start with and why. Again, even a trained data scientist may not know going in exactly which algorithm is the correct one. He or she may have to do some testing and comparison, and ML Studio makes that really easy to do. I cannot emphasize enough the fact that when it comes to operationalizing the model, building it, then making it available for programmatic calls to it, it's very, very easy to do. It's a button click in ML Studio. You'll see me do this at least once, maybe more. And the really cool thing is, once it's deployed as a web service, they even give you code samples in 3 different languages, R, Python, and C#, to help get you started writing code for your apps that calls out to that web service. Very, very cool stuff.
I like it.
I
Cool.
think we should build something.
Before we do that, I've actually got 2 real quick questions for you that
Yep.
bubbled up that I think are interesting. Number one is there a preference between R and Python? Is there certain cases where Python is better than R better than Python, or is it really just a matter of personal preference, that if you're already a Python developer, keep going down the Python path?
It's more that than anything else.
Okay.
So technically there's little or nothing that you can do in one of those languages that you can't do in the other. Mm-hmm. Here's what you find when you go out and work with universities and work in the research community. Most people who went to grad school to learn about machine learning and other aspects of data science did almost everything in Python. R is a little bit newer. R is really up and coming. So when you go out to those communities today, you still see a lot of Python being used. But most of the latest and greatest stuff is being done in R. And here's one of the really cool things about R. There are tens of thousands, if not hundreds of thousands, of R packages out there that are free. They're in the public domain that researchers can bring into their models and use. Okay. So R is really getting a lot of mind share in that community. In fact, I should point out, one of the things about Azure Machine Learning that is often not talked about is not only can you write your own R code into a model or Python code to customize it any way you want, there's even a mechanism for taking any of those tens of thousands of R packages that are out there and importing them into that model and just using them. In fact, I was working with some folks last week who are doing hardcore genomics research, using Azure machine learning. And they're using actually hundreds of different public domain R packages to do certain things in that model that are very, very specific to genomics research.
Okay.
Yeah.
Excellent. And then the second question is if there are already some pre-built experiments or really just something to go in and play with inside of Azure. So if maybe I just wanted to go in, kind of poke a little bit at machine learning, didn't necessarily have data, didn't necessarily have a model already pre-built, but I wanted to go look at one, are there any pre-packaged samples that I could use inside of Azure?
There are. In fact, you can go out to the Cortana Intelligence Gallery and find lots of machine learning models that are built with Azure Machine Learning. In fact, it's really cool. When I build a model in Azure Machine Learning, publish it as a web service and all that, if I want, with a couple of button clicks, I can publish it in the Cortana Intelligence Gallery so that other people can go out and download that model and benefit from it as well. So absolutely.
Fantastic.
Yeah.
I like it.
Yeah.